Hello everybody, welcome into another lesson. So today we are going to talk about transformations and reflections of the sine and cosine graphs. So here, just like when you have a polynomial function or an exponential function or logarithmic or any other type of function, same holds true with trig. You can have shifts where you're shifting horizontally, so you have a sine of the quantity of b times x minus h plus k, or y equals a cosine of b times the quantity of x minus h plus k. That x minus h denotes a horizontal shift along your x-axis. So of course you set the x minus h equal to 0. That'll tell you whether you're shifting it left or right. If your h becomes positive after doing that, you're moving it that many units to the right. Now, if this were x plus h, x would equal negative h, and then you would be going that many units left. And then that plus k part, that's a vertical shift, either up or down, depending upon whether you're subtracting. And like in the last lesson, your amplitude is that a. That's going to affect your range. So will any vertical shifts too. Those will affect your range. And then your period is going to be 2 pi over the absolute value of that b, because the period of both the sine and cosine function is 2 pi. So you take it and divide it by the absolute value of b, you have your period. And then we're also going to get into reflecting these functions. So let's say that coefficient, that a, your amplitude is negative. It reflects in the x-axis. It'll reflect everything in the x-axis. So let's go ahead and get started here. So let's do the first one. Say you have y equals the sine of x plus 2. So y equals the sine of x plus 2. Alright, so let's look for our amplitude. What's the coefficient on the sine of x? It's just 1, right? So that means my amplitude is 1. That's easy enough. Now, let's find the period. So we have the period. So what's the coefficient on the x for the sine of x? It's just 1. So that's going to be 2 pi divided by the absolute value of 1, which would just give you a period of 2 pi. Easy enough. Now, do you see an x minus number for that? You don't. So in other words, there's no horizontal shift. It's going to stay perfectly centered. But what about that plus 2? That means you're vertically shifting upwards 2 units. So there's a vertical shift up 2. That's what that plus 2 means. Also, let's look at the domain. So the domain, again, for the sine function, that's all real numbers. So from negative infinity to infinity, that hasn't changed. However, I promise you, your range is going to change with that vertical shift, because what's the normal range? The normal range, of course, is going to be from negative 1 to positive 1, right? However, we are shifting everything upwards 2 units. So your range is really negative 1 plus 2 and then 1 plus 2. Which means your range is actually going to be positive 1 to positive 3. So you have to take that vertical shift, add it to your range, so your range is now positive 1 to positive 3. So let's go ahead now, since we know the period's 2 pi, let's plot these points. So we have 2 pi here. Here's pi. 7.5. So there's 3 pi over 2. Here's pi over 2. Okay. Here's negative pi over 2. there's negative pi, negative 3 pi over 2, and then here's negative 2 pi. So again, you want to graph 2 periods worth. Now, like any place, let's start at 0. So what's the sign of 0? It's normally 0, but we got to add 2. So it's actually going to be at the coordinate 0, 2. All right, now let's look at pi over 2. So what's the sign of pi over 2? Well, it's normally 1, but then you got to add 2 to that. It's actually going to end up being at the coordinate 1, 3. All right, now what's the sign of pi? That's 0, but plus 2, that actually becomes 2. And then what about the sign of 3 pi over 2? That's normally negative 1, but plus 2 would actually give you positive 1. All right, now what's the sign of 2 pi? That's 0 plus 2 will actually give you 2. So we can go ahead and graph the right branch of this. Now let's go ahead and do the left branch. What's the sign of negative pi over 2? That's normally negative 1, but plus 2 would actually give you positive 1. Now what's the sign of negative pi? That's going to be 0 plus 2 is actually 2. Now what's the sign of negative 3 pi over 2? The sign of negative 3 pi over 2 is positive 1 plus 2 would actually give you 3. Then what's the sign of negative 2 pi? That's 0 plus 2 is going to be 2. So let's go ahead and draw the left branch of this graph. So as you see, it looks like the normal graph of the sine of x function, only everything's been shifted upwards 2 units, and your range is going to be from 1 to 3, as opposed to negative 1 and 1. So that's an upward shift of 2 units for the sine of x, and I got more. I got 8 more. All right, what do we got here? So, we have y equals the cosine of x minus 2. So we've been given y equals the cosine of x minus 2, okay? Well, let's look for the amplitude first. Your coefficient on the cosine, that a, is 1. So the amplitude's still 1. Now let's figure out the period. So what's the coefficient on pi? On x, excuse me. What's coefficient on x? It's 1. So your period, you're going to take that 2 pi, divide it by the absolute value of 1, and you'll get a period of 2 pi. So that hasn't changed. Now, do we have a horizontal shift at all? Is there an x minus anything for the x, or an x plus anything? No, so we have no horizontal shift. But that minus 2 means you have a vertical shift down 2 units. So there's a vertical shift down 2. So we're going to take everything, shift it downwards 2 units. Okay, now, again, what is your range? What's the domain? Let's start there. The domain for the cosine function, again, that's all real numbers. So negative infinity to infinity. But what about your range? Your range for the cosine, again, is normally negative 1 to positive 1, right? But we have that minus 2 for the vertical shift, so your range will be negative 1 minus 2 to 1 minus 2. So that means your new range is going to be negative 3 to negative 1. So your range is now negative 3 to negative 1. That'll be your new range. So now let's go ahead with all this information. Let's graph this. First, it would probably help if I plotted sufficient points, right? I always erase these because the period can change sometimes. 3 pi over 2. Here's pi over 2. negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Again, we want to show 2 periods worth. Okay. Now, what's the cosine of 0 normally? It's 1, right? But what's 1 minus 2? That's negative 1. So we'll actually be at the point 0, negative 1 when we're there. All right. Now, what is the cosine of pi over 2? Well, that's going to be 0, right? But what's 0 minus 2? That'll give you negative 2. All right, so now what about the cosine of pi? The cosine of pi is normally negative 1, but minus 2 would actually give you negative 3. All right, now what's the cosine of 3 pi over 2? That's 0, but minus 2 would give you negative 2. Then what's the cosine of 2 pi? That's normally 1, minus 2 would give you negative 1. So let's go ahead and draw the right branch of this. Now let's go ahead and go to the left branch. What's the cosine of negative pi over 2? Well, that's also 0. Minus 2 would give you negative 2. All right. Now what's the cosine of negative pi? That's negative 1 minus 2 is actually negative 3. What's the cosine of negative 3 pi over 2? That's going to be positive 1 minus 2 would give you negative 1. Now what's the cosine of negative 2 pi? That's normally 1 minus, wait a second, cosine of 2 pi, negative 2 pi is 1. You know, I messed up somewhere. Then what's the cosine of negative 3 pi over 2? That's 0 minus 2 is negative 2. Excuse me, I was off 1. That should be negative 2 here. See, good thing I caught it. Now the cosine of negative 2 pi is 1, but minus 2 will give you negative 1. Okay. There we go. Let's draw the left branch. And there is the left branch of this cosine function shifted downwards 2 units. So you can get some really neat transformations when you start shifting, and even better yet, reflecting, which we're going to get into here in the next example. So all right, now let's see here. We have the negative cosine of x plus 5. So all of a sudden now we have a negative cosine of x plus 5. Well, still, look at your amplitude. The amplitude is really the absolute value of a, which would equal the absolute value of negative 1. So that means your amplitude is 1. All right, so you have an amplitude of 1. Now, let's find the period. So what's the coefficient on the x? It's still 1, right? So the period would be 2 pi over the absolute value of 1, which would just give you a period of 2 pi, right? So that helps you. In fact, since we know the period is 2 pi, why don't we go ahead and start labeling our points? I just want to label all the proper points here. All right, there's negative pi over 2. Negative pi. 6, negative 3 pi over 2. And then, of course, negative 2 pi. So we have enough points for 2 periods. Okay. Now, do you see in parentheses an x plus quantity? You don't. It would always have parentheses if you're going to have a horizontal shift. So there's no horizontal shift, but you do see a plus 5 beside the cosine of x. There is a vertical shift up 5 units. So there's a vertical shift up 5 units. And then, let's see, what's the domain? Again, the domain of the cosine function is always going to be all real numbers. Now, what about your range? Again, the normal range is -1 to +1, right? However, we have a vertical shift upward 5 units, so we got to add 5 to each of those range values, giving us a total range from 4 to 6. So the range is now 4 to 6. All right. With all that information, let's go ahead and graph. And actually, that A is less than 0, we can also say a reflection in the x-axis. There is a reflection in the x-axis. So we can keep in mind this is being reflected. Okay, so what's the cosine of 0 normally? That's 1, but you have to consider that negative on the 1, so that'd be -1 plus 5 is 4. So you'll be at 0, 4 for that point. Now, what about at pi over 2? What is the cosine of pi over 2? Well, that's 0. Negative of 0 is 0 plus 5. That's going to give you 5. Now, what about cosine of pi is -1? If you negate the -1, you get +1 plus 5 is actually 6. Now, what's the cosine of 3 pi over 2? That's normally 0 plus 5 is going to be 5. Now, what's the cosine of 2 pi? That's normally 1, but if you negate that 1, add it to 5, you'll get 4. So now we can go ahead and draw the entire right branch of this curve. Now let's do the left. What's the cosine of -pi over 2? That's also 0 plus 5 is going to actually give you 5. Now what's the cosine of -pi? That's normally -1, so you negate the -1, you'll get +1 plus 5 will actually give you 6. Now what's the cosine of -3 pi over 2? Also 0, then plus 5 will give you 5. Now what's the cosine of -2 pi? That's normally 1, so you negate that 1, add it to 5, you'll get 4. So now we can draw the left branch of this curve. And there you have it. You have yourself a reflected cosine function shifted upward 5 units. When normally it'd be hanging down like this instead of like that because it's reflected in the x-axis. All right, 6 more. Alright, so we have the cosine of the quantity of x plus pi over 2. So this time you have the cosine of a quantity. Well, again, let's go for your amplitude. What is your amplitude? The coefficient on the cosine is +1, so your amplitude's still 1. Now, let's look at the period. If you have a quantity of the cosine of a quantity, you look at the coefficient outside of the parentheses, and your x should always be a coefficient of 1 inside the parentheses. Outside you may or may not have a coefficient. If you don't see a coefficient, that means your b is 1. So your period is still going to be that 2 pi over the absolute value of 1, which would just be 2 pi. And I just happen to keep up the other, I already happen to keep up the x points, so we don't have to rewrite those. Now, what else do we notice? So we do have a quantity inside of the parentheses, that means we have a horizontal shift. So there's a horizontal shift. This time it's going to be left pi over 2 units. So everything is going to shift to the left pi over 2 units. You're going to see what that looks like in a minute. Do we have any plus or minus outside of the parentheses? We don't, so there's no horizontal there's no vertical shift, there's only horizontal shift. Alright, now let's also look at the domain. The domain is still all real numbers, that hasn't changed. But what about your range? Well, the range is -1 to 1, and since we don't have any vertical shift, it's going to remain that. So your range is just going to be -1 to 1 since you don't have a vertical shift. Now we're ready to proceed. Let's start at x equals 0. Alright, so if we put in 0 for x, this really behaves like the cosine of pi over 2. And what's the cosine of pi over 2? That's actually 0. Now, what about if we put in pi over 2? Put in pi over 2 for x, that behaves like the cosine of pi, right? The cosine of pi is -1, so that's going to come down here. Now, if we put in pi, that would give you the cosine of 3 pi over 2, which would also be 0. And then what if we put in 3 pi over 2? That would be like the cosine of 2 pi, which is 1. Then if we put in 2 pi, you would get the cosine of 5 pi over 2. Well, it's really 2 pi, which is a full revolution of the circle, plus another pi over 2. So it's like the cosine of pi over 2 again, which is going to be 0. So we could start to draw this branch. Alright, now let's go to the left. What if we put in -pi over 2 for x? This would become like the cosine of 0, which would give you 1, right? Now, what if I put in -pi? That would become like the cosine of -pi over 2, which would be 0. And if I put in -3 pi over 2, that would become like the cosine of -pi, which would be -1. If I put in -2 pi, that would become like the cosine of -3 pi over 2, which would be 0. So let's now draw the left branch of this. And there you have it. This actually almost looks like a reflected sine graph as opposed to cosine. When we get into trig identities, you're actually going to see if you affect x, or if you affect the x quantity of a cosine function by pi over 2, it actually does become more cosine-like. And same with sine, it would become more cosine-like. So you're not wrong when you say this looks like a reflected cosine or reflected sine. That's pretty much what happened, actually. So it's pretty cool how one function can pretty much take on characteristics of the other, if you ask me. Why did I erase all that? I'm sure there's a reason why. Okay. We have negative sine of the quantity of x plus pi. We have negative sine of the quantity of x plus pi. So what's this going to look like? Well, let's look at for the amplitude. We know a equals -1, right? That's our coefficient. So the amplitude is going to equal the absolute value of that -1, which would be 1. So the amplitude's 1. Now, look inside the quantity for your sine, that x plus pi. That x coefficient is 1, and outside the parentheses you don't see a coefficient. So that means your b is 1, right? So that means your period is going to still be that 2 pi over the absolute value of b, which is the absolute value of 1, which would mean your period is 2 pi. And like a dummy, I forgot to keep these up, so I got a drum. I'll try to be quick. Whoa, not 3 pi over 3. There we go. Pi over 2. Negative pi over 2. Negative pi. Negative 3 pi over 2. And then negative 2 pi. All right. There we go. Okay. So, but look at your parentheses. You have x plus h, right? So that means you have a horizontal shift to the left pi units. So this is a horizontal shift left pi units. So we are actually going to go to the left by pi. And you don't have a plus or minus outside the parentheses, so there's no vertical shift. Now notice that a is negative. We have a reflection in the x-axis. That's good information to notate. And what else? Let's look at the domain. The domain still hasn't changed. That's going to be all real numbers. Negative infinity to infinity. Now what's the range? Normal range of sine is negative 1 to 1, and we have no vertical shift. So, and our amplitude's 1, so it's going to be negative 1 to positive 1. All right. So now let's go ahead and graph this. So what's the sine of 0? Well, if we put in 0 for x, this would be like the sine of pi, which is still 0. Negative of 0 is 0. So that hasn't changed. Now, how about if I put in pi over 2 for x? That'd be like the sine of 3 pi over 2, which would normally be negative 1. You negate the negative 1, you'll actually get positive 1. Okay, now what about pi? If I put in pi, that's like the sine of 2 pi, which is actually going to be 0, so that'll be 0. Now if I put in 3 pi over 2 plus pi, that'd be like 5 pi over 2. You subtract 2 from 5 pi over 2, it'd be like pi over 2. So what's the sine of pi over 2? Well, that's going to be positive 1. You negate that, you'll actually end up getting negative 1. Now if I put in 2 pi, well, that's like a whole revolution. That's a whole pi past a full revolution of 2 pi. That's going to give me 0. So now I can graph the right branch of this sine. All right, now negative pi over 2. So if I put in negative pi over 2, this would be like the sine of pi over 2, which is normally positive 1, but you negate that, you'll actually get negative 1. Let's put in negative pi. That would be like the sine of 0, which is 0. So there's your 0. Now if I put in negative 3 pi over 2, that would give me the sine of negative pi over 2, which would normally be negative 1. Negate the negative 1, you'll actually get positive 1. Then if I put in negative 2 pi, that would give me the sine of negative pi, which is 0. So there is the graph of my sine function reflected in the x-axis and shifted horizontally to the left pi units. So very interesting graph there. All right, I should have about 4 more. All right, so y equals the sine of the quantity of x minus pi over 2. Alright, so y equals sine of the quantity of x minus pi over 2. So what is our a? The coefficient on sine is 1, right? Which means our amplitude is also 1. So the amplitude is 1. Now, the coefficient on x in the parentheses is 1. That's good. And you don't see anything outside of the parentheses for a number. So that means your b is a value of 1. So your period is going to be that 2 pi over the absolute value of 1, which would give you a period of 2 pi. In fact, you know what? I'm going to keep this up because I'll give you a hint. All of these are going to be a period of 2 pi today. They chose to make our lives easier, make this whole thing a period of 2 pi for the lesson today. So that's going to help us. I'll quit erasing these markers on the x-axis. Okay. There. Leave these intact. Alright, now, we got our period, we got our amplitude. Look inside of the parentheses. You see x minus pi over 2, that means it is going to be a horizontal shift right pi over 2 units. So, horizontal shift, this time it's going to be to the right of pi over 2 units. Now, do you see any numbers outside the parentheses, plus or minus? You don't, so there's no vertical shift. Now, what's the domain? The domain is still all real numbers. Then what is your range? Your range is still that -1 to +1 because you don't have any vertical shifts, so your range is -1 to 1. All right. Let's go ahead and start graphing this. So I put in 0 for x. That's like the sine of -pi over 2. What would that give me? That would give me -1. All right, let's put in pi over 2. You would get the sine of 0, which is 0. What about if I put in pi, I would actually end up getting the sine of pi over 2, which is +1. Put in 3 pi over 2, that would be like the sine of pi, which is 0. Put in 2 pi, you would get the sine of 3 pi over 2, which would be -1. So now we can go ahead and graph this right branch. And then let's go to the left. If I take -pi over 2 and put that in for x, that'd be like the sine of -pi, which would be 0. Alright, go ahead and put in -pi. That'd be like the sine of -3 pi over 2, which would actually be +1. Put in -3 pi over 2 for x. That'd be like the sine of -2 pi. That would end up being 0. Now let's put in -2 pi. So that's a whole negative revolution around the circle minus another pi over 2. So that's like the sine of -pi all over 2 all over again. That'd be -1. So now we can go ahead and graph the whole left branch. And there is your function. And it looks like another oddly reflected cosine function more than it does anything, but it's technically still a sine function, just shifted to the right pi over 2 units. All right. That's good. We're almost there. I only had to erase one of the numbers. I can live with that. All right. Let's see here. So this one's going to be fun. The last three are going to be fun. We have y equals 5 minus the cosine of the quantity of x minus pi all over 4. Ouch. Ouch. Alright, so yeah, we got some shifting going on here. So let's see here. What is our a? What's the coefficient of a? So that's a -1 on the cosine, right? Your a equals -1, which means you have a reflection in the x-axis for sure. Let's start with that. Reflection in the x-axis. Now, to find your amplitude, you would take the absolute value of that a. So the absolute value of -1, that means your amplitude is 1. Now, let's look for the period. So the coefficient inside the parentheses on the x is 1. You see no number outside the parentheses, so that means your period is still going to end up being that 2 pi over the absolute value of 1, which would give you a period of 2 pi. So that hasn't changed. Now, what about for, let's see, let's start with horizontal shifts. Look at your parentheses. That x minus pi over 4, we're horizontally shifting it right pi over 4 units. Horizontal shift right pi over 4 units. Okay. Now, let's look at that 5. That's a positive 5 outside of all this, right? We also have a vertical shift. So you're going to have a vertical shift up 5 units. So now you have both horizontal and vertical shifts going. Okay. And then let's look at the domain. Again, the domain of the cosine function is all real numbers. Now what about your range? The normal range of your cosine function with an amplitude of 1 is 1 to 1. -1 to 1, right? So take that -1 to 1, but you have a vertical shift up 5, so on each of those you're going to add 5. So that means your range is really going to be from 4 to 6. Your range really goes from 4 to 6. Now with all this information, let's go ahead and graph this. So I'm also going to suggest another thing. Since we're shifting everything pi over 4 units, draw yourself a 45, 45, 90 right triangle, because that's what pi over 4 is. That's a 45-degree angle, right? So 1, 1, square root of 2 right here. Now we have a nice 45, 45, 90 triangle to refer to. Okay, so let's start when x is 0. When x is 0, that would give you the cosine of negative pi over 4, which would end up being negative square root of 2 over 2. But if you negate that negative square root of 2 over 2, you'll get positive square root of 2 over 2. Then you have a plus 5. So let's figure all that out. What is, let's see, the square root of 2 divided by 2 plus 5 would actually put you then at 5.71, roughly. So right about here. All right, now, what about then if we did pi over 2? Well, pi over 2 for x minus pi over 4 gives you the cosine of pi over 4. So that's going to end up then being positive square root of 2 over 2. But if you negate that square root of 2 over 2, so you would actually this time have 5 minus the square root of 2 over 2. Let's see, square root of 2 divided by 2. Let's see, then we take 5 minus that answer. That's going to give you about 4.29. So right about there. Now how about pi? Cosine of pi, so then subtract pi over 4, that gives you the cosine of 3 pi over 4. Now remember, the cosine of 3 pi over 4 is in your second quadrant, right? So that means it's actually going to be negative of the square root of 2 over 2, since your cosine's negative in the second quadrant. You negate that negative square root of 2 over 2, and then you add that 5, you'll actually end up back where you were at the 0 coordinate. So right about there, the 5.7 something. Now how about 3 pi over 2? At 3 pi over 2, you're going to then end up having, so let's see, that'd be like 5 pi over 4, which is in the third quadrant. That's another negative square root of 2 over 2. And if you negate that, you'll actually then end up getting then you'll end up getting add that plus 5, you'll end up back here again. So this is where your range of 6 comes in. It's going to happen at all points in between. It'll happen at all points here in between, like the pi and 3 pi over 2. At the actual 5 pi over 4, it's going to be like the cosine of pi, so which would give you -1. -1 would actually give you +1 plus 5 is 6. Heck, you know what? Just for this, we should probably label pi over 4. I get a feeling we may need that here. Let's do the pi over 4 units. That might make our lives a little bit easier. Sorry folks, but I would rather be thorough on this because we have a lot going on with the shift of pi over 4. You see just how hairy and how quickly this can get. Alright, anyway. Pi over 4, that'd be cosine of 0, which is 1. And then negative of 1, so that would actually end up being 4 down here. Alright. What did I say? Cosine of 0 is negative pi over 4. Actually, then it should be here. I ended up mislabeling this. I distributed a negative wrong. Okay, that explains a lot here. What's the cosine of, let's see, 3 pi over 4, so that'd be like the cosine of 2 pi over 4, which is the cosine of pi over 2. That's 0, and then you have a 5. There's pi over 2, 3 pi over 4. Alright, now, let's see, 7 pi over 4, that's like, so subtract pi over 4 from that, they give you 6 pi over 4, which is 3 pi over 2. cosine of 3 pi over 2 is 0. That would actually drop you back down to 5. Okay. And then you end up having 2 pi. So that'd be like 7 pi over 4. That's going to actually put you in the fourth quadrant, which would give you positive square root of 2 over 2. Negate that, take that away from 5, you'll be at 4.2 something here again. So there's the right edge of that curve. Now let's go to the left. If I take negative pi over 4 minus pi over 4, that's like cosine of negative pi over 2, which is 0, plus 5 would give me 5. Okay. Take negative pi over 2. In fact, let's just connect this as we go along here to make sense of this. Alright. Negative pi over 2, so that'd be like the cosine of negative 3 pi over 4. That'd be in the third quadrant. So that would give you negative square root of 2 over 2. Negate that, you'll get positive square root of 2 over 2. So that puts you up at like 5.7 something here. Now put a negative 3 pi over 4. What do you have? That'd be like then the cosine of negative pi, which is negative 1. Negative negative 1 is positive 1 plus 5 is 6. So you would actually end up then at 6. All right, negative pi minus pi over 4. So that'd be like negative 5 pi over 4, which is in the second quadrant. So negative of the square root of 2 over 2. Negate that, you get positive square root of 2 over 2. Plus 5, you'll be at the 5.7 something again here for the pi. So bring that down. All right. Negative 5 pi over 4, so that's negative 6 pi over 4. Negative 3 pi over 2, that's 0. Plus 5 is 5. We're almost done with this. Negative 3 pi over 2. So that'd be like negative 7 pi over 4, which is actually in the first quadrant. That's going to be square root of 2 over 2. You negate that, add that to 5, you'll get the 4.2 something. For the decimal approximation, negative 7 pi over 4, that'd be like the cosine of negative 2 pi, which is 1. Negate the 1, add it to 5, you get 4. And then to put in negative 2 pi, that's like another negative pi over 4 past negative 2 pi, so it's just the cosine of negative pi over 4. That'd be positive square root of 2 over 2. Negate that, plus 5, that would give you that 4.2 something. So yes, this one was a bit of a doozy, but there's your graph of 5 minus the cosine of the quantity of x minus pi over 4. So you see everything is shifted to the right pi over 4, up 5 units, and reflected in the x-axis. So you can get some very funky graphs sometimes. And it's my suggestion, whenever you have a shift that's not pi over 2 or pi, if it's anything else, add those intervals in between. Add the pi over 4 intervals in between. It's going to make your life a lot easier. All right. Got 2 more, folks. Then we're done. Now, second to last one. Y equals negative 2 minus the sine of, this one ain't so bad, x minus pi. Alright, so y equals negative 2 minus the sine of the quantity of x minus pi. Okay, let's look what our a is. So the coefficient on the sine is negative 1. So the a is equal to negative 1, which definitely denotes a reflection in the x-axis. And it also means our amplitude is 1 because that equals the absolute value of -1, so the amplitude is 1. Easy enough. Now, look at your parentheses, the quantity of x minus pi. The coefficient on x is 1. You have no number outside of the parentheses, so your period's going to be 2 pi again because it's going to end up being 2 pi over that 1 absolute value of 1, which just gives you a period of 2 pi. That'll make your life easier. Now, also look at your parentheses because you have x minus pi. That means you're actually going to shift to the right pi units. So this is a horizontal shift, right pi units. All right, now let's look at what's outside of this. You also have a -2, right? Which means you're going to vertically shift down 2 units. So we have a vertical shift down 2. All right, so let's go ahead now and, oh yeah, what's our domain? The domain is -infinity to infinity. That hasn't changed, but what's your range? So your normal range with an amplitude of 1 is normally -1 to +1, right? However, you have a vertical shift down 2 units, so you got to subtract 2 from each of your range values, which means your new range is -3 to -1. So you're going from -3 to -1 for your range. All right. Here, I tell you what, we're only going to worry about the pi over 2 units since we're shifting a whole pi. We're shifting a whole pi, so this isn't going to be so bad. Erase those pi over 4s so we don't have to fill in all those. All right. So let's put in 0 for x. So that would be like the sine of -pi, right? Which would be 0. And then just subtract 2, you would be at 0, -2 for that coordinate. All right. Now if I put in pi over 2 for x, that would be like the sine of -pi over 2, which is -1. Negate the -1, you get +1. So -2 plus 1 is -1. Now put in pi. Pi minus pi, that's 0. Sine of 0 is 0. -2 is, in fact, -2. Put in 3 pi over 2. That's going to be like the sine of pi over 2, which is, in fact, 1. You negate that 1, then add -2. You'll actually end up at -3. Then now take 2 pi minus pi. That's the sine of pi. Also 0 minus 2 is yet another -2. So let's go ahead and graph the right branch of this curve. And then we have a -pi over 2. So -pi over 2 minus pi. That's the same as the sine of -3 pi over 2, which is +1. So -1 minus 2 is actually going to be -3. Now let's see, -pi minus pi is -2 pi. Sine of -2 pi is 0. Minus 2 is -2. So then -3 pi minus 2, that's the same as -5 pi minus 2, which would just be -pi over 2. The sine of -pi over 2 is -1. Negate the -1, add, which would be +1. Minus 2 then is -1. And then -2 pi minus pi, so that would be the sine of -3 pi. 0 minus 2 is also -2. So let's go ahead and graph now the left branch. And there is your function with it reflected in the x-axis shifted to the right pi units, and shifted down 2 units. And actually, I think this will be the last exercise, because the next one is a cosine function being shifted by 3 pi over 4 units, and I don't think anyone really wants to deal with that. I think one example is enough. So next lesson, we're going to graph the secant and cosecant functions. We're going to see how those work. So I hope everyone has a great night. Take care.